Hello students, welcome back. Previously, we went through the technique of implicit differentiation. For instance, starting from an implicit relation like this, associate it to an implicit curve like this, resulting in the implicit differentiation like this in French notation, or like that in German notation. Remember all those? You should, because we are about to begin an example problem based upon this very relation. I'm talking about this one here, of course. See, the very same relation. And here is the structure of the problem. If x is 1 and y prime is negative 1, find out the values of y and x prime. Let's go back to this. We started from one equation and we ended up getting the second equation through the implicit differentiation. So we have two equations, but we have four unknown variables, xy and also x prime and y prime. But then again, two of them are given. X is 1, y prime is negative 1. So we have only two unknown variables with two equations. Yes, we can solve it. Maybe a little bit difficult, but we can solve it. So how do we do that? Well, here we have the implicit equation. And then we can take the derivative implicitly. Oops. X prime y plus x y prime 3y squared times y prime equals to 0. Remember all those? X cubed becomes 3x squared upon taking the derivative, but then again x prime pops out. And then in the middle we have a product rule, and y cubed becomes 3y squared, and then y prime pops out, and the derivative of any constant is 0. Remember all those? So we have these two equations to work with, and then plug in the numbers and you're going to get a system of two equations and two unknown variables. Here we go. Here's the implicit differentiation. All good. And then from here, let's plug in numbers. Let's see. Plug in numbers. Plug in x equals to 1, so 1 to the third power here, 1y, and then, yeah, that's 1, 2, and then that's 1, 2. Also, y prime is negative 1, so okay, y prime is negative 1, and then that's negative 1 as well. So after plugging in the numbers, we get these. Okay, like this and like that. Yeah, this one is better in my notebook because I use the color coding. Okay, so instead of that, let me copy and paste like this. Okay, a little bit better with color coding. And why did I duplicate all those? Well, that's because some simplification is in order, and as a matter of fact, in my notebook here, I assumed students are capable of doing all those. And I still believe yes, but, well, we're doing it here, so. All right, 1 to the third power is 1. Okay, 1 times y is just y. All right, how do you simplify this? Y plus y cubed is equal to 0. Is that what I'm getting? Okay, all right. And then down below, what is this? 1 squared, so that's just 1. Okay, 3x prime. And 1 times negative 1, that's minus 1. 3 times -1, so that's -3. Oops. Okay, that's right. Okay, did I get everything right? Yeah, so this became that. This became this, and it eventually became that. All right, this and that. How do you solve this system? Any idea? The key is to factor. You see, this is a nonlinear equation. For quadratic or cubic or whatever, the key is to factor. Keep the right-hand side equal to 0 and factor. From here, can you factor it? If you remember the factorization, this becomes easy suddenly. Yeah, let's copy and paste, and then let's just go over to the next step. Okay, that's where we are in right now, right? Factor y out, 1 plus y squared equal to 0. That's what you have right now. Factor y out, 1 plus y squared. Okay, which means either y is 0 or this has to be 0. You see, right-hand side is equal to 0. We cannot get 0 by multiplying two non-zero numbers. One of them has to be 0. So which is 0? Y equal to 0, okay, that's fine. 1 plus y squared, that cannot possibly be 0. Y squared is already greater than or equal to 0. And add 1, that's too big. That's strictly positive all the time. Greater than or equal to 1. So conclusion is y equal to 0. Let me emphasize that in bold. Bold green. So from the first equation here, plug in the numbers and some further simplification, we get y equal to 0. And key here is to factor. You see, if you have quadratic or cubic or whatever, keep the right-hand side equal to 0 and factor. All right, now that y equal to 0, I can plug that into the second equation. Y equal to 0, so multiplying by 0, isn't it? And this one here, 0 squared, so multiplying by 0 squared. That's the equation we have, and of course, there's no reason to multiply by 0 and write like this, because multiply by 0, that's just 0, it'll drop out. Multiply by 0, that's 0, it'll drop out. All I get is 3x prime minus 1 is equal to 0, and oh, that's an easy equation to solve. I get x prime is equal to 1/3. Okay, original and then implicit differentiation. Plug in the numbers and then work a little bit further. Let's see. Yeah, all those, but then again, it's gonna be a little bit better if I open up all these. Let's see, some simplification. We got up to here. Yeah, that's basically what we did before. And what we do here, how do we solve? The key is to factor. From here, factor. And we ended up with y equal to 0. Plug that into the second equation. Easy solution. So that's the process. Step 1, implicit differentiation, original and implicit differentiation. Okay, so we have 2 equations and 4 known variables. Now, plug in the numbers. Plug in the numbers to this and that. And what we have first equation and the second equation. And only 2 unknown variables. You see, x is 1, y prime is -1, so those two are settled. So we only have x prime and y. So here, equation number 1, and there, equation number 2. Two equations and two unknown variables, we can solve it. Some further simplification, we ended up with still a system of two equations. Equation number 1 and equation number 2. Nonlinear equations, so it's going to be more strategic to keep the right-hand side equal to 0. And then what do? Factor. Factor, and you get one of the variables settled. And then substitute. We get the other variable. So, was this straightforward? Probably not. This is hard. Nonetheless, this is a kind of problem that appears in related rates. X prime and y prime are related in a certain way, and how do you determine which one based upon whatever condition? That's the kind of thing we are doing here.